Oh, yeah, she won't get it. Wow, shoot.
All right. What do we got left? 36? Now, 33. All right, how many people got 33, 34, 35 right but missed 36? Okay, I think you all did the same thing wrong probably. What you were supposed to do, here's my guess. Okay, here's my guess. You took where they said the integral of f of x was 18, you put an 18 there. And they said the integral of g of x was 5, and you put a 5 there. Is that right? Am I looking at the right one? Okay, and 3 times 18 is 54, and 4 times 5 is 20, and that 54 plus 20 is what? Is that the right answer? 74, and that was what I read was the right. Oh, I didn't read that one. 74 is the right answer. And that's wrong. That's lucky, but it's wrong. Okay, because here's what you were really supposed to do. You're supposed to use the rules like we just did a minute ago. You're supposed to take this 3 and pull it out, and then f of x dx, plus, and then this 4 pulled out, g of x dx, negative 2 to 5. Now, this integral is 18. This integral is 5. So 3 times 18 is 54, plus 4 times 5, which is 20, which is 74. Now, what you guys were doing is you were substituting an 18 right there, right? You were just taking 3 times 18, I think, many of you, 4 times 5, adding together, and you didn't do anything with that integral symbol. You didn't do anything with the negative 2 to the 5, didn't do anything that had to do with area, right? And it only worked because the way the formulas work is splitting them up and multiplying by 3 and so forth. And that's why you ran into trouble on 36. Okay, because 36 says this. The integral from negative 2 to 5 of h of x plus 1 dx. And the integral of h of x is what? Negative 11. The integral of h of x is negative 11. So many of you did negative 11 plus 1, got negative 10, and that wasn't the right answer, right? The right answer is supposed to be negative 4. There's 2 ways you could do this. One would be the way we just talked about 36 right there. We could split it into 2 integrals. Like so. This would be very much like we just did on number 26. Okay, what is this integral? Now what that means is there's some function h, we don't know what it is, but its area under it from negative 2 to 5 is negative 11. That's what that's saying. Okay, what is this? That's a horizontal line, y equals 1. And it's the area from negative 2 to 5, which is 7 wide and 1 tall, which is an area of 7. So this integral is 7. So negative 11 plus 7 is negative 4. Okay? Good chance you'll have to do something similar to that on the quiz that we do over this stuff. I want you to know the properties. It's a good way to make you do the properties. Now, another way to think about this one. And try to put yourself back into the mode we were in back when we were in Chapter 1, Chapter 2, learning the concepts of derivative. And I told you over and over about how it's not enough to kind of just put in some numbers, get the answers or whatever. You've got to really understand the concept of what's going on. And I think eventually you guys will realize that. How you can't just get by with kind of thinking you got the homework. You really need to understand what the questions are asking, what's going on, because you know there's so many different ways the same kind of question can be asked. You got to get the concept out. Well, we're kind of back at that point again. We're starting something new. There are a lot of connections to what we had before, but we're in that phase right now where we're learning the notation. and we're learning some of the intricacies of the notation and what it means. So really force yourself to think about it and what it's saying. And if you don't get it, ask questions. Okay? Very important. So one way to do it would be to split it up. Another way to do it is to just think of this as a graph. Now, how does that compare to the H graph? Shifted up 1. So we were given an H graph, or we were told that the H graph from -2 to 5 had an area that was -11, correct? Now, obviously, that's not -11 because that's above the x-axis, right? It should be below. But it just makes this easier to show if I show it this way. Okay, well, if I take this H graph and I shift it up 1, now I've got that graph. Now, I've obviously added some area to it, right? How much area have I added? Well, by shifting it up 1, oops. Well, in a sense it's negative, right? But it's still adding to it because it's adding a positive to it, right? I mean, so it's, but so in a sense, what's happened is I've still got this piece of area right here. That wouldn't this area right there, wouldn't that be the same as the original area? That's the -11. What have I added on by rising it up? I've added this rectangle, I've added this box of area. So by taking that whole graph that had a straight bottom and taking that and shifting it up, what I've added is that strip at the bottom that's 7 wide and 1 tall. So I could have thought my way through it that way. I could have just, same thing if this would have been a +3. If it's a +3, that means I shifted it up 3. I've added a rectangular strip of area that's 3 tall and however far this is wide. And you could just think it that way. So you wouldn't have to go through this whole process. So you'd say, well, I have that -11, but then I've added a strip of area that's 7, and that makes a total of -4. So I could have done it that way. Okay? So that's the idea of 36. All right, I got one new thing to show you today. Well, 2 things. One of them is not really new. So this, okay, this first one is all right, this first one is this. It's the idea of average value of a function. Average value of a function. And so we're going to have a formula. Okay? We're going to have a formula here that you're going to have to memorize. Average value of a function from x equals a to x equals b. Now, I think this is on page 309. And the formula is this. The average value of a function from a to b is the area from a to b divided by b minus a. That is the formula that you need to memorize. It does a little bit. It has a connection to something, but we're not going to give it away just yet. It's such a secret. There are several secrets that I'm going to try to keep in the next couple days, and some of you are going to stumble onto, so don't ruin them for me. All right. So, so if you happen to think it, you know, just be quiet. All right. But anyway, average value of a function. Now, what's that mean? So what we're saying is, all right, and let me bring up a picture here. So here I've got this blue function from a to b. Doesn't it make sense that there is some average y value? If you took all these blue y values, there'd be some y value that'd be the average. Does that make sense? Now, usually we do the average, you add up all the points and divide by how many there are, right? How many y values between here and here? Infinite. So obviously we can't add them up, okay, to do that. But it makes sense that somewhere there is an average. Now, we could kind of guess where we think it would be. Okay? Would that be reasonable? Wouldn't we need some of the y values below, some above, kind of in the middle, kind of a thing? So it seems reasonable that this y value right here might be the average value, or something very close to there. Okay? Now, you notice that that created this pink rectangle. Okay? Now, also notice we've shaded in blue the area under the curve, which would be that integral. Now, is it also reasonable that as I found my guess, as I found my y value, that I thought would be kind of the average of those blue values, is it also reasonable that that pink box area is the same as this blue shaded area? Yeah. And wouldn't that be reasonable for the same reasons? In other words, if my y value here is the average because I have about the same number of y values above as I do below, doesn't that also make like this area kind of account for this area, and maybe this area kind of account for this area, and it kind of makes those equal. So as I move this, and I say, well, that's too high, and that would also make that area not match, right? Does that make sense? There'd be a connection there, okay? So it seems reasonable. So that would mean, back to our formula, well, so that would mean that that blue area, which would be the integral from a to b, that blue area seems to equal that pink area. Now that pink area is a rectangle, so it would be the width, which would be what? What would be the width of that pink rectangle? B minus a times the height. What's the height? Well, it's the average, it's what we're calling the average value, right? The y would be the average value. And so do you see where the formula comes from? Just divide both sides by b minus a. So it would seem that if this blue area is the same as that rectangle area, and this is the rectangle area, if we divide by, basically we're saying take the area divided by the width, and that gives you the height of the box, which is the average value. And so that's where that comes from. So what's that mean? Well, you're going to have problems mostly later on, some in here, where they give you a function, say, this is the temperature. This is the function for the temperature over the course of a year. What's the average temperature for the year? Well, you would set up an integral, 0 to 365, of the temperature function, divided by 365 minus 0. And that would give you the average temperature. That would be an example of where that comes. Okay. So that's one formula that we have in this section. You'll have some problems where if it says find the average value of the function, or what's the average of this, or whatever, go to this thing right here. Okay? And then the last comment I would make is that they give you a problem where they talk about car talk. And we got to go back to some stuff we've talked about with velocity. If I give you a velocity, if I give you a velocity graph, okay, this is a velocity graph. What does it mean, first of all, when you get to this point right here? So the thing, let's say it's a car. The car is stopped. It was going right, let's say, because it was positive velocity, and now it's going left. And then it stopped again, going back to the right. What would this area represent here? The distance it traveled. Because think about this. This would be miles per hour up here, and this would be hours down here. And so if we think about area, we did this at the beginning of the year, it'd be rate times time. It'd be miles per hour times hours, and that's going to give you distance traveled. This is going to give you distance traveled, right? But that's negative. Remember I mentioned displacement? I think I mentioned displacement yesterday. If you add this positive with this negative, that's displacement. Because what happens? It moved to the right for a while, then it moved back to the left. So if it went to the right for 10 miles and came back to the left for 8 miles, what? its displacement was 2. In other words, it was still 2 miles to the right. But that's where that negative comes into play in a real life situation. So they have a problem with velocity in there, and it says explain it in car talk, meaning distance traveled, that kind of stuff. So that's why we want to do this whole thing of area integral. All right, here's your homework. Get out that assignment sheet if you would. This quiz, that's a great question. This quiz will probably be at the end of next week, Thursday or Friday. The quiz will be over sections, well, you can see it on there, sections 1, 2, and 3. Now, this little packet I gave you is the LH packet that's referred to throughout there. Well, I actually have several of them to give you. Your homework is to finish the top line, starting with 38, moving on. And then also to do the LH packet that I just gave you. Now notice it says page 289. That is not the front page of the packet. The front page of the packet is 279. So you need to turn to the second page of the packet, which is page 289. Now, look at number 1 on the packet, please.
So then we do numbers like 1 through
You do number 1, number 3, 11 through 17 odd, and 18 through 20 on the packet. Yes. So just look at number 1, please, just so it's very easy. The first couple, and then 11 through 17 odd, those are just where, like today, you draw pictures, and it'll make triangles and rectangles, and you do the areas. But on number 1, the directions say write the integral. Okay, this is on page 289. 289 would be the back of the front page. Number 1, it says set up the integral. That's all you have to do. Does somebody want to tell me what that'll be? For number 1, integral symbol 0 to 5, 3 dx. That's it. That's all you're doing. Right? Because what goes in where the 3 is, that's f of x. We have f of x dx. Well, in this function, the function is 3, so we put 3. So it's very simple. Just get you used to the notation. Here's an area. What would the integral be that describes that area? It's all you put for number 1. Okay? All right, that's your homework for tomorrow.